In homework 5.1, you're asked to factor each expression and then to solve by factoring. This is a super important skill we're going to use all year long. You want to be awesome at this. I'm going to walk you through how to factor in case you have forgotten from Algebra 1. Factoring, what the word means is to see what multiplies to make the original expression. So if we have a C and we factor it, we're rewriting it as A times B. You did this in middle school when you had like numbers like 6, and you would factor it. 6 factored is 2 times 3. We can do the same thing with these trinomials. The way you factor a trinomial is super easy if there is no number in front of the x squared. And there is no number here, so that makes it really easy. If there's no number in front of the x squared, we can just say, hey, x times x is going to give you x squared. And then we need to figure out how to fill in the rest of this. The way you figure it out is you think to yourself, okay, this will be a number and this will be a number. And the two numbers will need to multiply to make the number. The number times the number gives you the number. So they're going to multiply to make 8, and they're going to add up to be 6, and we'll see why in just a second. The two numbers that multiply to make 8 that add up to be 6 are 4 and 2. So this factored is x plus 4 times x plus 2. That's our answer. If you want to see why, I'll show you real quickly. The reason why this works is because when we multiply x plus 4 times x plus 2, you distribute. X is going to multiply times both of these. X times x gives you the x squared. That's good, that's what we wanted. X times 2 gives you 2x. 4 then distributes. 4 times the x gives you 4x. And 4 times the 2 gives you the 8. Notice the only thing that has the x squared in it is the x times the x gets you the x squared. The only thing that just has the constant is the constant times the constant gets you the constant. The middle terms, you get x times 2 and 4 times x. Both of those have an x in them, and you combine them, you add them together, and that gives you 6x. So this is why the numbers we're looking for need to multiply to make the constant, but add to be the variable term. This can be a little bit trickier when the numbers are bigger or when they're negatives, but it's never too bad. X times x gives you the x squared. We're looking for two numbers that multiply to make negative 100 that add to be 15. And if you don't see it right away, what I recommend doing is first thinking of what the signs have to be. The constants need to multiply to make negative 100. To multiply to make a negative, there has to be a positive times a negative. If you still don't see it, then what I recommend doing is just writing out the different factors of 100. And I usually just start with 1. 1 times 100 gets you 100. But 100 minus 1 doesn't give you 15. Then I go to 2. 2 times what gives you 100? Well, 2 times 50 gives you 100. But 50 minus 2 doesn't give you 15. Then I go to 3. 3 does not go in evenly into 100, and if you're not sure how to tell if 3 goes in evenly to something, the way you tell if 3 goes in evenly is you add up all the digits, 1 plus 0 plus 0, and that's 1. And if 3 goes into the sum of the digits, then 3 also goes into the number. But because 3 doesn't go into 1, 3 also doesn't go into 100. So 3 doesn't go into it. 4 does go in evenly into 100. 4 times 25. 25 minus 4 is not 15. 5 goes in evenly because it ends in a 0. 5 times 20. And 20 minus 5 does give you 15. So x has to be 20. It's x plus 20 times x minus 5. There are some slightly easier ones. Like for instance, if there are no x's in the middle, this will always be the exact same thing and you don't have to think about it real hard. You want it to be automatic. To multiply to get x squared plus minus 9, well, x times x will give you the x squared. These two numbers need to multiply to make negative 9, and what they'll have to add to be is 0. There are no x's. This is called the difference of two squares when there's no x's in the middle, and the only way to make it happen is if the constant multiplies to make negative 9, but they add up to be 0. And the way you add up to be 0 is having the exact same thing, but one is positive, one is negative. So it's just the square root of 9, one is positive, one is negative. 3 times negative 3 is negative 9, 3 plus negative 3 is 0. A couple other tricky things that come up sometimes. On number 9, oh my god, there's a cubic. This has x cubed in it, x squared and x. Well, the first thing you should notice is that we don't know how to factor cubics unless there are very specific situations, and this is one of them. In this case, they all have a common factor. And remember from Algebra 1 that if there's a common factor, you can factor out the common factor. This is x times x squared plus x minus 20. This is now a quadratic and can be factored even more. X times, we bring down this x, it's still going to be multiplying to make it. This we can split up even more. X times x gives you the x squared. We need two numbers that multiply to make negative 20 that add to be 1. It's positive 5 and negative 4. 5 times negative 4 is 20. 5 plus negative 4 is 1. So this completely factored is x times x plus 5 times x minus 4. Let's see. They get harder near the end here. 2x squared plus 11x plus 12. What is different about this one is this 2 in the front. When there is a number that is not 1, it makes it tremendously more difficult to do. And there's not a super easy or super fast way. I'm going to show you how to factor it. Remember, what we're looking for is two things that multiply to make this. The difference is it's not just going to be x times x gives you x squared. There's going to be a number in the front, and that kind of messes everything up. I'm going to show you the tic-tac-toe method for factoring numbers when there's an a in front. This also works for the easier ones too. It just is a little bit longer, and so you only want to use it when the problem is hard. You don't want to waste a lot of time on easy problems doing it this way. It's great for the hard problems. The way you do the tic-tac-toe method is you set up a tic-tac-toe board, and you put the first number, a, in the top left. So 2 goes there. Then c is the next number over, 12. The middle number, 11, goes to the bottom right of your tic-tac-toe board. This is how you're always going to set it up. You put the first number, the third number, the coefficient of x squared, the constant, and then the coefficient of x goes in the bottom right of the tic-tac-toe board. So, the rules of the tic-tac-toe board is that you multiply when you're going to the right, and you also multiply when you're going up. So, we can fill in one number really easily. 2 times 12 is 24. Now, all of these numbers will multiply going up. What we use this 11 for is it's the last piece of the puzzle, which is these multiply going up, and they multiply going to the right. These two numbers also add to be 11. So this is the same as what we've been doing. We're looking for two numbers that multiply to make 24, that add to be 11, and that's 8 times 3. So 8 and 3, it doesn't matter which order you put them in here. 8 times 3 multiplies to give you 24, and they add to be 11. The last thing is, since it multiplies going both to the right and up, the number that needs to go here, we want to go to this left middle section, is going to be the greatest common factor of 2 and 8, because it has to multiply to make both 2 and 8. And so the number that multiplies to make 2 and 8 is 2. From here you can fill it out. Remember, it multiplies going up, so we need a number times 2 that gives you 2. And that number is going to be 1. We need 1 times a number, and multiplies going to the right. 1 times a number gives you 3. 1 times 3 gives you 3. 2 times a number gives you 8. 2 times 4 gives you 8. And one last check. 3 times 4 does give us 12. This is correct. The answer is in this bottom left portion of the tic-tac-toe board, and it's on these diagonals. Here we have 2 and 3. It's going to be 2x plus 3. The numbers in the left column tell you what gets the x. That's because that lines up, these line up. This is 2x and x. 2x times x gives you 2x squared. 3 times 4 gives you the 12. These are the constants, and they're diagonal from each other. 1x plus 4 is just x plus 4, and this is factored completely. The last one I'm going to help you with is number 18. Number 18 has two variables in it. It looks super weird, but there's an easy trick we can do, which is that when you see two variables, you always want to look and see, is there a common factor to make it easier? And these do have a common factor. They both have an a. They also both have a 2. And so, just like above, we're going to start by factoring out our common factor. 2a times what gives you 2ax squared? Well, 2a times x squared gives you 2ax squared. 2a times what gives you 18a? 2a times 9 gives you 18a. And now we have just a quadratic with only one variable, we bring down the 2a, and this can be factored. This is that same difference of squares we saw earlier. X times x, and it has to multiply to make negative 9, but add to be 0. So it's plus 3 minus 3. 3 times negative 3 is negative 9. 3 plus negative 3 is 0. On the back, you need to solve each equation for x. We're solving for x here. I'm going to skip the first 3 because the first step is already done for us. The first step when you're solving a quadratic equation is to get it equal to 0. The reason is you can't, when it's a linear equation, you can get the x by itself, no problem. But there's 2 different x variables. And so there's no way to get x by itself if you do traditional methods because there's 2 different x's. Instead what we do is we make it equal to 0. And the way we do that is we subtract on both sides. We get x squared minus 3x minus 10 equals 0. Notice that the 10 can't be subtracted from either of these because it's not a like term. So now that we have it equal to 0, this looks a lot like the ones on the front. We can factor this. This is x minus 5 times x plus 2. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. These multiply to give you the original trinomial. The reason we factor it is because now we can get x by itself. And we use something called the zero product principle, which says that if you have 2 things multiplying times each other, which we do, we have 2 things, a times b. When we have 2 things multiplying times each other to make 0, the only way to multiply to make 0 is if the first one is 0 or the second one is 0. So either a has to equal 0 or b has to equal 0. That means that either x minus 5 has to equal 0 or x plus 2 has to equal 0 because these multiply to make 0. We can set up 2 linear equations that say that. Either x minus 5 has to equal 0 or x plus 2 has to equal 0. These are linear equations that can easily be solved. X equals 5, we add 5 to both sides. X equals negative 2. These are our 2 answers, x equals 5 or x equals negative 2. What you're going to do on all of these is you're going to factor them, make it equal to 0 first, factor, and then use the zero product principle to see what each term could be. One thing that some people will do, and this is fine if you're smart about it, is they'll just say, hey, what number can go in for x here to make 0? Well, 5 minus 5 is 0, so x is 5. What number can go in here for x to make 0? Well, what plus 2 is 0? Negative 2 plus 2 is 0. And that's fine, but be careful, because I see some people do something terrible, which is they say you just switch the sign, and that's wrong. Okay, it worked here. You just switch the sign, but when they get a little bit harder, it will not work. For instance, here, we need to make it equal to 0. And this time there is no number in front of, there's a number in front of the x squared. And so we cannot just use our easy factoring. We're going to use the tic-tac-toe method. A quick reminder of how it works. Remember, the first number goes in the upper left. Then the last number, the constant, negative 15 goes here. And the x's go in the bottom right below the tic-tac-toe board. The rules are it multiplies going to the right. So 2 times negative 15 is negative 30. It multiplies going up, but also these 2 have to add to be 7. So we need 2 numbers that multiply to make negative 30 that add to be 7. And that's going to be positive 10 and negative 3. Negative 3 times 10 is negative 30. 10 plus negative 3 is 7. We now find the greatest common factor. The greatest common factor of 2 and 10 is 2. 2 times 1 is 2. 2 times 5 is 10. And we fill in using the rules. What times 2 gives you 2? 1 times 2 gives you 2. 1 times what gives you negative 3? 1 times negative 3 gives you negative 3. 2 times what gives you 10? 2 times 5 gives you 10. And so negative 3 times 5 gives you negative 15. It worked. Remember that the factors are found in this diagonal. So the factors are 2x minus 3 times, this other factor is 1x plus 5. I'm just going to write x plus 5. The dangerous thing here is that, yes, negative 5 plus 5 is 0. But if you just turn this negative 3 into a positive 3, that will not make this factor equal to 0. If x is 3, 2 times 3 is 6. 6 minus 3 is 3. That is not 0, and so that is not a solution. 2x minus 3 has to equal 0, or x plus 5 has to equal 0. To solve this, we add 3 to both sides, and then divide by 2. X is 3 halves, or x is negative 5. Those are our two solutions. The last one, I'm not going to solve for you. It's a little bit different, and I love it. Here we have ax squared plus 3 times ax plus 4. This looks super weird. The trick to recognize here is this is a quadratic. You're going to use what's called a substitution. I'm going to say let u equal a times x, and I'm going to rewrite this for you. U squared plus 3 times u equals 4. Notice ax just became u, so instead of ax squared, it's u squared. Ax became u, so instead of 3ax, it's 3u. And this is a quadratic equation. You can solve it very easily, and what you'll end up getting is u equals something. But you are not done. We weren't looking for what u equaled. We wanted to solve the equation for x. So once you find what u equals, you'll get 2 answers. You're going to take each answer and re-substitute back in. If u equals these 2 answers, then a times x equals each one. And so you'll get 2 different equations that ax could equal, and you'll need to solve each one for x by dividing by a. I hope this helped. I hope I didn't give too much away, and you remember how to factor from Algebra 1.